So here we go. All right, so who remembers, it's been a few days since we did this, who remembers how we even begin to approach this? We got to change everything into sines and cosines. So that's what we're going to do. We're going to change everything into sines and cosines. So what's cosecant? 1 over sine. Good. What is tangent? Sine, and this time it would be sine squared over cosine squared. What is secant? 1 over cosine. And what is cotangent? Cosine over sine. Now, I can't impress upon you enough how important it is that you know those, so you can do this problem. Now, anything on the top can cancel with anything on the bottom because this is all multiplication. So, I have a cosine here and a cosine here. I have 2 sines on the bottom that will cancel with 2 sines on the top. I think that's it. So I have 1 on top and cosine squared on the bottom, which you are allowed to leave that. That is fine. Or you can rewrite it as secant squared, because 1 over cosine is secant. So either way is totally fine. Does anyone have a question about that? Okay, so we're going to memorize what these are, right? It's time. If you haven't already, you need to get that done. Okay, then the second one was a little bit harder. All right, so now I see a squared in there and a 1. And I know that there are 3, we call them Pythagorean identities, that have 1s and squareds in them. So there's one that says sine squared plus cosine squared is 1. That's probably not the one I'm going to be using. There's one that says 1 plus tangent squared is secant squared. I'm not using that one either. But there's one that says 1 plus cotangent squared is cosecant squared. That's the one I'm going to use because my problem has a cosecant squared and a 1 in it. Now, they're not arranged like this though. It's cosecant squared minus 1. So I need to move this over here so it will say cosecant squared minus 1. And what will that equal then? What's left over here? Subtract the 1 from both sides. So now it says cotangent squared is the same as cosecant squared minus 1. So this guy is cotangent squared over cotangent. That's going to cancel, and the answer is cotangent. What's wrong, Mason?
As soon as I turned it in, I forgot. I knew that I forgot to put this away.
All right, anybody have a question about that? Okay, all right, you can put those away, and then we're going to finish our note sheets now, which I heard we're on page 43, and we're ready to start with problem number 2. All right, So we're on page 43. We're going to do problem number 2. Find the area of a parallelogram. Okay, so we got to remember what a parallelogram is. The sides are 14 and 16. And the smaller angle is 48. Now, when you eyeball the parallelogram, can you tell that one of these angles is smaller than the other one? So it says the smaller one is 48. And we're going to find the area of that guy. Okay. Well, we have 3 ways of finding area of triangles. The old-fashioned way is 1/2 base times height. It'll work, except we don't have the height, right? We have Hero's formula, which is awesome. It's the one with the big radical, remember? What do we need to know if we're going to use Hero's formula, though? What information do we have to have? All sides. And then we have another area formula that says the area of a triangle is 1/2 side times sine of included angle. Now, I hope you remember this.
Yes.
Talked about it last week. Now, at this point, I don't even have any triangles in my picture. So I'm going to go ahead and draw this in. Is that okay with you if I draw in that diagonal?
Yeah.
Now, that creates 2 congruent triangles. These triangles are exactly the same. So if I find the area of this one and times it by 2, I should have the area of the whole parallelogram. Would you agree with that?
Yeah.
All right, so let's do it. Look what I've got. 2 sides and the included angle. The included angle is the angle that's between the 2 sides. So the area of this triangle, very simply, is 1/2, what? 16 times 14 times, oh, not cosine, sine 48. And you might remember that if you just remember 1/2 side sine. 1/2 side sine.
83.63.
What?
83.
Okay, that's this one. Okay, now remember, we need to take it times 2 to get the whole parallelogram. The parallelogram is 2 triangles. So what is it?
166.46.
166.46 is, and that would be square centimeters, is what Ethan says. What do you think about that? Is he right? No issues? Everybody's good? Okay. 1/2 side sine. That's one way we have of finding area of triangles. All right, now number 3 says, go back to the same picture. So we've got our parallelogram out of 48, 14, 16. And we need to find the length of the longer diagonal. Okay, now wait a minute. Again, just eyeballing it. These are the diagonals, right? Can you tell that one of those is going to be longer than the other one?
Yeah.
Just by the way things are situated. This is going to be the longer diagonal. And I want to find the length of it. Now we're not going to use the Pythagorean theorem, right? Why? It's not a right triangle, so there's no Pythagorean theorem going on. That means we're either going to use the law of sines or cosines. But I don't have enough information. I need more information about the angles. I need to know something about the angles in this triangle. Can anybody help me?
Divide 48 by 2.
Now, the diagonals of a rhombus bisect the angles. The diagonals of a parallelogram do not. This is not a rhombus. If it were a rhombus, these two numbers would match. So these are not 24. It's a very common mistake, but no. Nope, 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 nope. Huh?
180 minus 48.
This angle right here, and likewise this angle, are 132. The reason those are 132 is because these are parallel lines. These are consecutive interior angles, and we know that when parallel lines are cut by a transversal, consecutive angles are supplementary. They add up to 180. Remember all that stuff about alternate interior and all that stuff? Alternate exterior, all those crazy things. These are consecutive interior angles, and consecutive interior angles are always supplementary. They add up to 180. So now I've got this triangle right here. I'm looking at the top one. And I'm going to say x squared equals, I'm going to use my law of cosines. Who remembers it? X squared equals, look at I'll erase this part here, we can get this out of here. Just in this triangle right here, what would the law of cosines say? X squared equals what?
Side squared plus
So it'd be 14 squared plus 16 squared minus 2, always minus 2. Oh, there's more. Minus 2, 14, 16, cosine 132. That is your law of cosines. And we can just type it in. Very good. 14 squared. What do we have to remember to do always? Square root it. Please don't forget that step. And I got the longer diagonal to be 27.42 centimeters. All right, TJ, you following along okay?
Yeah.
You sure? Look a little tired. All right, one more problem. Find the area of a regular pentagon inscribed in a circle with a radius of 28. Okay, so here's our circle. Pentagon, regular pentagon. What's pentagon mean? 5. So I'm going to make 5 little hash marks and connect these dots. So there's my pentagon inscribed in a circle with a radius of 28. We did one just like this last week. You remember? What was our strategy? We broke this up into all the triangles, right? So we drew in all the spokes. And we recognized those were all 28s, right? Now we're going to find the area of this thing. So right now we're going to focus on one triangle because all these triangles are the same size. So if we could find one of them, we'll just times by 5 and we'll have it. This angle is 72. How did Ethan know that? 360 divided by 5? Kids, 360, right? The whole revolution here? All the way around? So now, look what you have. You have two sides, and you have the angle in between. So we can find the area. The area of the triangle is 1/2 side times side times sine of included angle. Bless you. Remember your formula, 1/2 side sine. So then we can type all that in. And I got, okay, I have to be careful. I got the triangle area to be 372.81. But I gotta be careful because I'm supposed to be finding the area of the pentagon. So what am I gonna do with this number? Times it by 5. So my area of my pentagon is 1864.07 square inches. What do you think about that? We okay? Everybody good? Okay, good deal. All right, so that's it for the note sheets. Don't lose this packet though, because chapter 7 starts on the back of it, so we want to keep those. Put those in a safe place. And now we're looking at our practice test. This is the one that's stapled wrong because I ran it through the machine wrong, sorry. Alright, so let's go to practice test number 2, please. Everybody's going to practice test number 2. You are going to have a calculator for this entire test, the whole thing.
Where are we going? What are we going?
Practice test number 2.
The pre-test thing?
It's called practice test, yes.
Memorization. We have so many that I've got it.
Alright, so we're on practice test number 2 for 5.1, 5.5, and 5.6. And problem number 1 says simplify this. Alright, this is practice test number 2. We're looking at number 2. And this is the first problem. Okay, we need to get started. If you can't find yours, just take a picture of somebody's and do the notability thing or whatever. Here we go. Alright, this is just like the quiz we just went over. What are you going to do first? This, what's cosecant? No, cosecant is 1/sine. And that is divided by 1/cosine. Now, when we divide by a fraction, we multiply by its reciprocal, right? So this is going to be 1 over sine times cosine over 1. And when I multiply fractions, I go straight across. So I have cosine over sine, which is cotangent. Very, very good. All right, does anybody have a question? This was the problem. Step 1, 1 over sine divided by 1 over cosine. But when we divide by a fraction, we multiply by its reciprocal. So we have cosine over sine, which is cotangent. Multiply straight across. All right, and then we have our Pythagorean one. Now, you have written on your green sheet something about cosine squared. Because this one was written down on paper. But underneath it, you remember what I had you write, or next to it or something? What did I have you write?
1 minus sine.
1 minus sine squared equals cosine squared. Or 1 minus cosine squared equals sine squared. Now, what does that mean? That means that whenever you see a cosine squared, you are allowed to replace it with 1 minus sine squared. So now, if I do that, I have 1 minus sine squared over 1 minus sine. Now, we haven't done one of these in a few days, but we did do several where we factored this. This is called the difference of squares. How does that factor? 1 minus sine and 1 plus sine. And when you do that, what happens? You can cancel. And your answer is just 1 plus sine. Now, I know this very first part here is going to be the hardest part of the test. Remember, you don't get points if you don't write something down, okay? So if anything comes to you at all, even if you can't go anywhere with it or you're not sure, write it down so I can at least maybe give you partial credit. I can't give you anything if you leave it blank. Okay? Now, the rest of the test, though, should be pretty easy for you, hopefully. Let's look at this problem that says solve the triangle. And we want to find side A, side B, and angle C. Okay. Now let's all focus. We can do this. We got this. What?
We have to find the missing angle.
We gotta find the missing angle. And Paul, how do you do that?
180 minus 029.
The missing angle is easy. It'll be 180 minus 73
49.
minus 58. 49, okay. So that's done. So there you go. Everybody's got that point for sure. All right, now what do you think about the sides? Now I need to start finding the sides. What's an idea you have there? Law of signs, because we got a pair right here. So we'll say sine 49 over 10 equals, and then, yeah, we'll say sine 58 over A. Or we could have done the other one, right? The order we do these doesn't matter. We're going to have to do them both. Luke, turn around. Marissa, be quiet. So sine 49 over 10 equals sine 58 over A. Okay, and now what? Cross multiply. So A sine 49, I am cross multiplying, equals 10 sine 58. So A equals 10 sine 58 over sine 49. I got 11.24. Now can I just do the Pythagorean theorem? No, it's not a right triangle, right? So what do? I do the same thing. So I'll say sine 49 over 10 equals, what do I need? Sine 73 over B. So B sine 49 equals 10 sine 73. And B equals 10 sine 73 over sine 49. I got 12.67. Did I type that in right? Yes. Does anyone have a question about any aspect of that problem? Got it? Okay. Well, the next one is the same thing, except, well, I mean, obviously the information's different, so let's see how things might be different. So we need angle D, angle F, and side E. Anybody have a thought on this? Law of cosines. Why are we thinking law of cosines? Because I don't have a set. Very good. All right, so what's my law of cosine going to say? I'm going to find side E, because that's the angle I have. So I'm going to have E squared over over here by itself.
Side squared plus side squared. Minus 2.
So that will be what? Then put numbers in for me.
Squared
16 squared
plus 10 squared.
plus 10 squared.
Minus 2 times 16 times 10 times 52.
Very, very good. So now I'll just type that in on my calculator. And as always, when I type this in, I have to remember, I want you facing the front. Okay, cut around, this total front. When I do this, I need to remember to take the square root. So E is 12.78. Everybody good with that? But we're not done. Now we need the angle. Caesar, got any ideas about the angles here? Very good. Look, guys, look what we have now. Now we can use our law of sines and say, like he said, sine 53 over 12.78 equals sine D over 10. Some of you, when you write your law of sines, you get things turned around. Remember, it's always the sine of the angle. Okay, so it's the sine of the angle. So the sine of D and this is one of the tricky ones. I have to remember when I type this in, I'm going to guess right. I'm going to get a decimal. But in order to get the angle, I'm going to have to do what with this decimal? Second sign it. Very good. And that angle D is 38.68. Remember, when you type this in, you're going to just get point something. That's not the answer. You have to second sign it. To find an angle, to get the actual angle, you're always going to have to second sign or cosine or whatever function you're using. Okay? Now, what? All I'm missing is angle F. But I know these two. Can't I just add those up and subtract from 180? And I got 88.32. All right, so our test is going to have two problems on it, just like this, that say solve the triangle. One of them, we started off with the law of sines. The other one, here, this one, we started off with the law of cosines.
Good God.
Okay. All right, so we need to start here tomorrow.
What do you think our test will do?
Let me just read this. I'll figure that out today. Thursday, maybe, Thursday, Friday. I'll figure that out today.
Where are you going to go?
All right, so good job. Get your